This is the slide that I'll be using, and the first one, 6-1, Introduction to Ontology and OWL. Okay. So the outline of this lecture of this slide is that first it will discuss about this is okay. What is ontology, and then the language or the representation that we can use to represent ontology, and then we will be doing some practice session using pizza ontology as an example. Okay, so a little bit, what does it mean by ontology? Ontology is the term that refers to a shared understanding of a domain. So we kind of design or model ontology in order to make a shared understanding of a certain domain. And it means that how it is related to our semantic web technologies or semantic technologies describing the thing, because with ontology, we can provide machine readable and machine understandable content. So the focus is to make this shared understanding of a domain in a way that can be used for machine to process the content. Okay. And let's look at a few definitions of ontology defined by several researchers. Okay, so ontology is not new term. It has been defined. If I refer to this, for example, from 99, 93, 91, and so on. Okay, so what does it mean when we say that share understanding of a domain? Okay, so it means that, okay, this one is easy to understand. It defines basic terms that people will use to refer to things in a particular domain. Basic relations. Okay, so basically what we use in our class, right? Vocabulary. We are defining terms, relations, or in other words, vocabulary of a certain topic area. This is the same thing as what we mean by a domain, right? A domain is an area of the things you are interested in, as well as rules. Okay, rules could mean condition, relation, restriction, axiom. Okay, so this is one definition. Another, okay, not very clear, but kind of short one, but it doesn't tell. If you don't understand ontology that well, you may not understand this so much. Explicit. Okay, this is good. It's explicit. Specification of a conceptualization. Actually, everything we are doing here is to make a conceptualization of things in a topic area, right? Conceptualization about terms, relations, axioms, rules. Yeah. Okay. Then another definition, for example, it gives more detail of how ontology is like as well, such as it is a hierarchical structure, a set of terms. So it's a term that could be hierarchically structured. And actually the usage of ontology is for construction of a knowledge base for a topic area, right? For a particular domain, particular application. And what else? Okay, let's move further for another description. Ontology provides the means for describing explicitly the conceptualization behind the knowledge representation in a knowledge base. Okay, this doesn't add more. Okay, but anyway, so I would like to refer to this short definition, but expand further. Okay, ontology is a formal. When something is formal, it means that it has been defined in a proper way such that certain meanings are defined as well, and in a form that machine can process easily. No ambiguity, very precise. Okay, that's formal. It's explicit, and it is an explicit specification, means that you need to make known the terms, right? Remember, we say terms and relations, and actually to clarify further, it means concepts, properties of concepts, certain relations, even functions, constraints, axioms. These are things that can be defined within ontology. And when it is a shared conceptualization, it means it is widely accepted. It's consensual knowledge. It's not only you that agree. It's agree upon the community of things, domain, okay? And when it is conceptualization, what does it mean? It means an abstract model. It's an abstract model, a conceptualization or a view of something you want to represent in the world, such as could be an ontology of computer science, could be ontology of as we see in examples this morning. What are they? What did you present? In health tourism, yes. Nutrition, exercise duty, right? Yeah, the classification of exercise duty. These are the domain, the conceptualization of things inside this domain, including the classes. Concepts means also could mean class. So actually, what we learn in RDF schema, they are also a kind of simple RDF schema itself allow us to define a simple ontology, because we can define terms, relations, properties, concepts, classes, right? You can even have the hierarchical structure of superclass, subclass, 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 and so on, right? This is actually, we already learned, but we will learn more, okay? And ontology itself, it is a formal approach for knowledge representation. So actually it's one way. It's not like when you say about knowledge representation, it must be ontology. No, ontology is just one mechanism, one possible way of representing knowledge in computer. And okay, ontology is engineering artifact consisting of vocabulary. This is what we already discussed, right? Vocabulary for describing a certain domain, okay? And it has semantics. when you are defining vocabularies, you need to define the semantics, right? The meaning of those vocabularies, and the way to define the meanings are actually through what we have learned so far, but we learn more. That is through organize the concepts in terms of hierarchy. Does it help you to define the meaning? Yes, because this is more specialized, this is more generalized, this is also the meaning, right? This concept or class has properties, these are also meaning. This concept has relations with other concepts. This is also the meaning. You define the meaning of how things are related to. Okay. This is the same thing. Okay, just different ways to define. How can we use ontology? Actually, it's kind of knowledge based, right? It's a knowledge representation language. So you can use it for knowledge base and database applications. This can be kind of foundation for knowledge layer, database layer. It can be used in certain applications such as building certain software agents, domain application, domain independent applications, problem solving mechanisms, and so on. I think in several of the papers you presented and you listened today, there are kind of examples, right, that we use ontology to serve as knowledge construct for answering and recommending certain things to the users, right? Okay, so some components, okay. When we talk about ontology, there are 4 main components that we can define or model. First, concept, class, category, type. These are kind of synonyms or similar, have similar meanings. Okay. So actually, we want to represent concepts in a broad sense, such as animal, university, person, and so on. Remember your own refer back, think back, your RDF schema that you model. You define classes, many classes, right? You define subclasses. These are first components. And don't forget as well that don't mix, okay? Those modeling principles we learn still apply. What does it mean by instance? Don't mix it with the class, okay? We are an instance of the class person. For example, you are an instance of a class student, okay? So there is no class Chuttipon. Chuttipon is cannot be a class because I'm not a blueprint. I cannot have Chuttipon instance so many things, right? I'm an instance, okay? All right, that is the first component. Second, yes, once you have class, you can have instance or individuals or objects, okay? These are synonyms. And next component, actually you already defined, right? In IDF schema, class may have properties or relationships with other classes. Sometimes in other theory, they may use the term slot, the same thing, okay? Or attribute. They may mean the same thing. Another one, the last component. This is what I already mentioned. Rule or axiom or constraint. They are used to define some kind of conditions that you may want to impose, restrict. We will see some examples. I skipped something first. Okay. Okay. When we talk about elephants, Okay, I want to define an ontology about elephants, related to elephants. Is my first question. 1, 2, 3, 4. Is elephant a class, instance, relation, or constraint? What is an elephant? Okay, I heard 2 answers, and that is always the case because it could lead to some confusion. I'm not talking about particular instance. I'm not talking about particular, elephant. I'm talking about elephant. When I talk about elephant, do you have any conceptualization pop up in your mind here? Maybe draw it here. Okay, draw it. Okay. Yes, but itself, what is it? It can be a concept. It can be a class, right? Okay. But if it is an instance, then we are talking about an individual elephant. Maybe you have one at home. Suppose it is a pet, okay? Raise one at home, that is an instance. But if we talk about general concept of elephant, that look like this, having big ears, having this, having long nose, and very big mammal, right? This is a class, okay? So it can be a class or we can call it a concept. You can think of a concept elephant. You are not referring to a specific elephant in this world, right? Then that can be modeled as a class. And it can be a subclass of animal. How about adult elephant? Is it a class or is it an instance? Also a class, yes. Okay. It is also a class, but then a subclass of elephant, right? Elephant is more general. Adult elephant is some specific type or subtype of elephant. Okay, good. But then adult elephant alone, maybe when I tell you an adult person, what do you mean? What do we mean? In general, the concept of an adult. Pardon? Oh, okay. Are you an adult? Again, age is greater than some value. What is that value for adults? Definition? Internationally, do you know? 18? Yeah, human. 18 in your country, above 18, you consider 18 and above, consider an adult, that you can do anything. Because if you are not an adult, you are a child, right? Not adult, then means child. You cannot do something, right? An adult can do this, and that without asking permission from parents by law, right? That is definition of adult in general. Why do we need to define? Because of course, by law, there are some things children alone cannot do. So in your country, what is the age? 18? 18, you can do almost everything. Okay, married, getting married. Without getting permission from parents. Huh? Mm-hmm. What is the restriction? That means you have to be older than 21. Then you can. How about 20? No. Oh, crossing 20 doesn't allow. Even going to a pub or something, a disco pub, something like that, we must be above 21. Mm-hmm. Okay. All right, good. Back home, Thailand, what is the age for adults? 18 or 20? You're not sure, or you want to give two answers? Okay. So can you get married now? Above 20 already? Okay. Yes, I mean, that is in Thailand, yes. But as I said, internationally, I'm not sure, but different countries may have different rules or laws. But for example, adult, we consider a person to be adult in Thailand when they are 20 or above. Then they don't need permission from anyone. But if they are below and there are certain things, they still consider a child somehow, that if suppose like getting married and doing something, they still need permission from parents. Or if they do something wrong, commit a crime, going to jail, for example, there is jail for youth and young people, and jail for kind of prisons for common anyone, right? So below 20, you can still go to the we should not call a jail, right? It should be called a kind of special home or something. Yeah, something like that, in which the case, I mean, if someone commits a crime and he is an adult, I think the sentence and the things will be considered that the person has already has been mature, right? Mature enough so that we cannot have an excuse that, oh, they are still very young, they may not have a maturity, something like that. Okay, then it is very important to define, right? What is the age definition for being an adult? Okay. Anyway, so adult elephant is also a subclass of elephant in which we may need to give some definition. And this is an example of a rule or somehow to defining class or subclass. That is, an adult elephant is an elephant, of course, is a concept whose members must be elephants and age must be 20 years or over. In my example, okay, I'm not sure, I'm not an expert in elephants, but let's assume, okay. And another thing, we will not consider it as adult elephant if it's too skinny, too small. So I have two definitions here, such as 20 years over and weight at least 2,000 kilograms. Okay, then these qualify a given elephant to be adult elephant. Okay, and we can further classify elephants into African elephants and then Indian elephants. So again, these two are classes or instances. Classes, right? Because we are not talking about a particular instance. We are talking about African elephants as a whole, Indian elephants as a whole, in which, do you know how are they different? Not only geographically. So if I show you photos of elephant, can you tell me this is African or Indian? Not sure. Aha, interesting. The one from online, do you know how African and Indian elephants are different? Size? So which one is bigger? Ears? African elephant has bigger ears. Yes, very big. How about brains? Brain size. Which one are smarter? The smarter must have bigger brain size, right? So African is what? Lakash, what are you explaining? African has bigger brain or what? I mean African elephant. I think Indian elephants are smarter. Okay, from what I recall, they have bigger brains and smarter. Okay, I could be wrong, sorry, but I think I learned from documentary. Anyway, so these are examples of classes, subclasses, concept, hierarchy that we can define. So what does it mean? It means here that, okay. It means actually we do have, of course, oops. Above, maybe we may have animal, we may have mammal, we may have many more, okay? But then we do have elephant. Under elephant, of course, there are a way to define as adult elephant. And adult elephant, okay, I just take some notes, okay, is defined to have age greater than 20, yes, thank you, plus weight greater than 2,000, okay, kilogram. And actually, there's also African elephant, okay, plus Indian elephant. All of them here are classes. Okay, we are defining classes hierarchy. So these are in terms of number one component, right? But here, actually, I think for number 3, you can see that it means somehow for elephant, we somehow want to define age and weight, property, right? But maybe not only for elephant, any animal, we may define from the property from the superclass, right? That animal, every animal has age and weight. Maybe you can even define it to have some name and many more, right? And then remember, properties from superclass can inherit to subclasses, right? So something that are defined for the superclass, we have inheritance concept here. So these are class. Oh, this is number 1, class. And then Then number 3 are kind of properties. Actually, these are example of number 4, right? You can define some axioms or rules that if for adult elephant, age must be like this, weight must be like this. And then for number 2, instance. Meaning that, okay, let's try. Okay, I can draw, okay. Oh, today I'm doing good. Okay, this is in my zoo. I do have this elephant. Maybe I call this elephant Mali. Okay, sorry. Okay, and Mali, this is the name. It has age. It is an elephant. It has age 21. It has weight 2,200. Okay, let's say this. So these properties and the values of Mali. This is an elephant. I can only say that it is an elephant instance with the properties, values, and so on. But then, if I ask you, is Mali an adult elephant? Can you answer me? Yes, it is, right? If I change the value of Mali, okay, she is now 15 years old only, but she overweight. Sorry, she eats a lot. Is she an adult elephant? No, she doesn't qualify the conditions, right? Okay, so this ontology, this is an example. Ontology can do some kind of, what is this? What is this thing I asked you? Sorry. This is called reasoning. This is a reasoning that computer can do. So what does it mean by reasoning? It means that you derive new knowledge, even it is not known. But there might be some rules, some conditions, some concepts defined, and something that is known, but you derive something additionally that is not known or not given explicitly. That is called reasoning as well. So reasoning means also oops, not this one. Actually, this is ontology, right? I did not write in some order. But given all these four components of classes or concepts, properties, instances, and then rules. This is what we define in an ontology. And actually, we say that it is a kind of modeling and knowledge base. And ontology is a kind of knowledge representation, KR. Okay, to model a knowledge base, to model a particular domain, conceptualization, and so on. So these things are model. Remember, we say that we define them as explicit knowledge, but still you can derive or yield something that is implicit. When you can do that, we call that we can perform some kind of reasoning. Okay, let me give another example. We already saw one example of the Mali, whether she is an adult elephant or not, right? Let me give another example. This is John. Okay. This is Mary. Okay. If I say Mary is a wife of John, I only say this. Okay. What implicit knowledge you can infer? Pardon? They are married. Yes. Okay. I tell you only one thing, right? You telling me something else that I have not explicitly defined. Anything else? Yes. So John is a husband of Mary. Yes. Yes. But how do we know that? Is it known by everyone? This thing? We know this because actually there is some rule saying that if A is wife of B, I can tell that B is husband of A. A can be anyone, B can be anyone, as long as they are human person. Okay. Maybe we are not talking about animals, right? Or maybe we can, okay? If this same knowledge applies. But anyway, so this is because this is what? Rule. You know this rule. If you don't have this rule, if I ask a little kid of 5 years old, maybe that kid doesn't know this rule. That kid cannot derive this knowledge, right? But you know. The same. If we give this knowledge known by a computer can and we tell computer only this fact. Then, you know, I am always confused. Sometimes it happens here, sometimes it moves there. This kind of bar. Okay. This yellow is explicit things. Blue is kind of derived knowledge based on this rule. If we define this rule, okay, together with this knowledge, these facts, we know facts. or data, then these blue things can be derived, right? They must come together. And this applies to any other example as well. If you can define some rules, some class, some concepts, some properties, plus certain knowledge and some rules, you will be able to perform a reasoning to derive something that may be not explicitly defined. Okay, and that is why we need to do, that is what we learn in knowledge representation. We represent knowledge, but you don't want to represent everything explicitly, right? Sometimes you want to kind of compactly represent something as knowledge rules. Then you can only store data only smaller, okay, and store it in the knowledge base. So in my knowledge base, I can store only the yellow parts and leave alone all the blue part to be reasoning, to be part of the reasoning results. Okay. All right. And that is what we can do also with ontologies. It allows us to make precise representation, expression of knowledge, of domain concepts. It allows us to share the knowledge to other people. And once we share, suppose you are new to the world. This can be shared and then you learn, right? This is the way to share knowledge and learn. And it allows inference or reasoning, okay? Okay, and then we can use ontologies to allow more of the shared understanding of domain, overcome differences in terms of terminology. Then we can define precise terminology, no ambiguity. Okay, we can even define mappings to say that this term and this term are the same, have the same meaning, or this term and this term is more specialized, generalized or specialized through subclass, superclass. We can have, like, as you said, same as, right? Our same as in the movie example, you can define that this thing here and this thing there is the same thing, but maybe called differently, but they are the same thing. Through subclass, superclass, you can define something is more general, more specialized, more specific. Okay. So that is ontology in a nutshell. Then we can talk about the language, because that is the concept, right? To understand that ontology must comprise these 4 components. Then how can we define an ontology? We need some syntax, some language, so that we can exchange and explain. Okay, so RDF is one. RDF schema is the vocabulary language for RDF, right? Then we have OWL. I think this morning we listened to many presentations that talk about OWL. It stands for Web Ontology Language. Don't ask why it is OWL for Web Ontology Language, but it is. Maybe they don't want to call it WOW. No, it doesn't read easily, right? For European people, for people, we want to make it short as possible. WOW is difficult to pronounce, so OWL is easier. Okay, so Web Ontology Language, but short for OWL. Okay, anyway, RDF we know about already. Notations of RDF in terms of the graph notation, RDF XML notation, the triple notation. Okay. Okay, this one is just Mona Lisa. It's painted by Da Vinci. And RDF schema we already discussed. Okay. This is the schema side. Remember from your assignments 1 and 2, we have the RDF description side, the schema or vocabulary side. Okay, don't forget that. You learn about defining class, defining property, subproperty, class, subclass, domain, and range, and so on. This is what we already learned. Okay. Okay, now web ontology language, OWL. If we look at the, no, I don't have it in this version, but I should bring it. Okay, one moment. Let's try this. I forgot my own slide, not here. How come? Okay. Okay, just look at this, right? Remember, we have so far learned up to, okay, here already, oops. Here already. Now we are here. So this is OWL. And it stands for Web Ontology Language built on top of RDF. That means it has RDF as a foundation. So it builds on the knowledge and structure and the formalism defined by RDF, meaning that the concept of subject, predicate, object is still there in ontology, in OWL. OWL is just one possible way to represent an ontology. There are many other ways to represent ontology in many other languages, okay? But OWL is one way. And it can be represented as a graph, as XML, as triple, turtle, and many more like JSON, IDF JSON. I think Pojanan presented this. It has 3 sub languages, right? Like the full, each of them have differences in terms of expressive power. What does it mean? A language that has more expressive power, is it better? What does it mean by expressive power? When you speak some language, and suppose that language has very limited expressive power, such as, suppose I define my new language, Chutipan language. I have only 200 words in my vocabulary of Chutipan's language. Do you think my language will be expressive? For sure, there'll be things I cannot explain, I cannot express in my language, right? That is the meaning of expressive power or expressivity. So this increase light DL full for sure, right? Must look like it is the full language, express everything. DL stand for description logic. Okay, it makes use of one logical framework approach called description logic. Light is of course smaller, so everything is a subset and superset. Full contains everything. DL is one subset inside full. Light is another smaller subset inside description logic. So anyway, the lower these sub languages, the more the expressive power it is. But then, what does it mean? You think it's preferable to use high expressive power language, right? If you want to speak something, you want a language, you want to speak a language with lower expressive power or higher one. And in which context you may want to do what? To use what? Okay, thank you. Good point. So actually, the trade-off, you may want to, of course, express everything. We will, in most cases, we will feel like having more is better, but it means also that it may require more processing power. When the language or when you are using something heavy, because it allows 1,000 features, but that means computing time would be more too. If you are using something lightweight, it may be faster. Okay, that is the trade-off. Okay, anyway, we are not up to full for sure. We will be focusing on light and DL, because when you're using the full power and your ontology is huge, it would take a lot of computing resource too. But we are not having the very huge ontology, and we don't need that full power in our in most of the application. I think DL is fine. Okay. This we already discussed, right? We can express everything as ontology in OWL too. In our OWL, common prefix, of course, is OWL, as you already saw in the movie database, movie knowledge base that we use for OWL same as, right? I think you saw one, okay, at least for sure. Of course, it has associated namespace to link with. Okay, this is kind of standard prefix that we use. You can define a class using our class, or RDFS class is kind of equivalent. You can use both. Okay. In terms of property, there will be I'll define two concepts for properties, two sub-concepts, subclasses of property. That is object property or data type property. The differences we will consider. Okay. The differences. Okay, I already discussed this. The differences is that if, remember, subject, predicate, object, subject, predicate, value. This property P1, the domain is the class for subject. The range will be the class for the object, right? This property P2, the domain is for the class of the subject. The range is some kind of literal value. This is data type property, while P1 is object property. P2 is data type property, because the range is a kind of data type like string, date time, Boolean, something like that. Okay, we will look at this in more detail. Okay, we consider this already, expressive power and efficient reasoning support. We will come back to this point. Reasoning, so on and so on. Okay, we will talk about this later. And Okay, let's have a break and we come back to some practice parts with Protege. So everyone be sure you have your Protege ready, install and usable. Actually, I have not installed on this machine, but I will explain what we are going to do and let you do on your own machine. Okay, let's come back around 15 minutes, more or less. Okay, I try. 2:25.ลงได้ยังหมายถึงตัวนี้เหรอแล้วตัวนี้อ๋อโอเคตัวนี้ลงไม่น่ายากรีบลงเนาะเพื่อนหลายคนลงแล้ว Okay, I'm back. Let's let me see. I have a few sets of slides. Which one I will use? Okay. I already uploaded this slide into the classroom as well. So let me refer to this one because it has been newly produced last year and more update detail. But the previous set of PowerPoint or slides is also fine. Actually, most of the contents are kind of the same. But anyway, what I'm going to explain now, the share screen. Yes. No, it's screen. Is it there? Screen sharing successfully? Did you see it? The other friends could. Did the screen sharing? Yes. But how can you see the sharing? Okay, maybe you misunderstood this sharing stuff. I need to share the whole screen. Okay, let's see. Okay, how about this? All right. Then this one, we will talk about Protege a little bit. Then we will start doing the creating an ontology, and we will use a domain of pizza to be an example ontology to create. Okay, and do a few things. My target is that we should finish around 3:30, I think. Then that, otherwise it's too much for today, and then I will leave you to do some practice. Okay, so the plan is I go through this quickly. You don't need to follow step by step, but maybe once you understand the whole picture, then after this you can carry on and do the practice on your own machine. Okay, but understand the concepts and the things together first. Okay, first a little bit about Protege. Okay, it is a free and open source platform available on Windows, Linux, Mac, and so on. It has GUI user interface to help editing, creating ontologies, modifying, revising, changing, even doing some reasoning and a few other things. So actually, I did not introduce this from the beginning. We can even use it to create RDF schema, RDF description, Sparkle query as well. But I want you to do it from scratch and from the ground too before trying to use the tool. Otherwise, you will never look at the syntax. You would just use the click, click, click interface. Okay. All right. It can support several other syntax as well, and query, as I already mentioned. Sparkle is possible. DL will be description logic is also possible. Let me see on here. Okay. And then, no. How can I allow this? Okay, maybe I cannot make it full screen and enable the pen. All right. Plugin. Okay. Later on, please try to install plugin as well, because we may need this. I mean, the bare Protege may not be equipped with so many things, but Protege allows a lot of plugin development and installation. So this one, it's called Snap Sparkle Query. It allows us to do Sparkle Query with Protege and the ontology that we create. Okay, follow all these things, okay, later on. Don't do it now. Okay, let me talk about pizza ontology. We will use pizza as an example of creating an ontology. When we, okay, I need some example from here. Okay, sorry that I switched back to this one. The thing is, why do we need an ontology for a pizza domain? Let's assume that I want to create a pizza ontology for my pizza restaurant. And I want my pizza restaurant to be equipped with some kind of recommendation for my customers, such as you. The thing is, sometimes customer and okay, before my restaurant, pizza restaurant has a lot of variety of pizza and maybe so many pizza, and our customers may have not known a lot of pizza or may have some queries, may want to ask about specific pizza to eat and for recommendation and so on. So what I would do is that I want customer to be able to ask questions related to the pizza that they want, such as some customer may want to say that I am vegetarian, but I have problem with spice. So please recommend vegetarian pizza with least spicy. Or maybe I have another customer, maybe a cheese lover, and who come and say, I love cheese. I want pizza that's full of cheese. Top with 4 types of cheese, 10 types of cheese, or something like that. Maybe I have another customer coming and ask, I am in favor of seafood. Any pizza with seafood? Okay. Or some may say that I want some pizza with this and that ingredient. Any kind of pizza that contains such specific ingredient. Or someone could say that I want to eat pizza with wine. What types of pizza that goes well with some wine that I like? Something like that, okay? So this is the thing that I want the ontology to be the kind of knowledge foundation that supports question answering recommendation of the menu to my customer. So actually, the very first thing for creating ontology, and it is very similar to developing a software, that is, you need to define the scope, because ontology is a domain conceptualization, right? So how big is your domain that you want to conceptualize? How small it is, or how deep it is, how broad it is? This is what you have to define. But how to define it? The easy way, I think this morning we have Pochanan saying methodology approach, but in this approach, I will simply explain the similar thing, that first you need to determine the requirement and scope. The way to determine the requirement and scope is through what we call competency questions. What kind of questions your ontology should be able to answer? Give yourself some idea, okay? Maybe, of course, it can answer thousands of the questions in general, but you may need to give some direction, broad, specific questions, okay? Okay, such as, I may want my pizza ontology to be able to answer this kind of question, such as, what pizzas have both capers and anchovy but no meat? So this indicates that your pizza ontology should have knowledge of ingredients, right? That's it. You can change meat, caper, anchovy to cheese, to spice, to this and that, but it knows ingredients. So your ontology, now the scope, at least from this one, it tells that somehow ingredient need to be model. But if you want your pizza ontology to answer things about price, which pizza is cheaper than 200 baht, for example. Oh, okay, then you know that not only ingredients. Our customer are care for price and cost. They have to pay, something like that. Or which pizza has origination from, pizza must be Italian, right? But somehow, let's say, kind of fusion pizza originated from Thailand idea of the menu or something. Then this gives you the scope of how your ontology should cover. Okay. Okay, so this is already what I said. It indicates in this example, indicates basic content and scope, indicates ability that it should be able to answer things related to toppings, or sometimes something like categorization. This is specific topping of the pizza, right? This is no meat. This is not specific, not about instance, but this is about categorization or class, that the class of topping should be nothing that is under the class meat, right? This is categorization. Okay. And these are another, some other example. Which pizza characteristics should I consider when choosing a pizza? Vegetarian, non-vegetarian, ice cream, vegetarian, okay, pizza base, and so on, the spicy. I think that's all from this that I should have said. Okay, so let's move to another one. So let's see and focus on this CQ, okay? For example, this is what we already consider, the pizza with some kind of toppings, such as mozzarella, tomato, but no meat. Or pizza from specific countries, as I already mentioned. Pizza that is kind of made for specific customers group. Thin or thick bread, that is kind of thin bread or thick bread. Types of cheese, even how about calorie? Yes, right? Maybe we're concerned about calorie. And even something like counting. Okay, I am kind of topping lover. Top me with so many toppings, okay? All right, and then finally, we may need to think that in this way, what and how do we define classes for our ontology? Remember, your ontology needs class, property, or relation, right? Axioms or rules. And instance. These are things you need for your ontology. Okay, the 4 components. On this screen, it has only the classes. First, the first thing to define in an ontology is to start from class. So in this case, we have something like, okay, let's start from food, a little bit upper level. because pizza is the type of food, a kind of food. Okay. In OWL, everything is a thing. So the topmost class will be thing. So anything you create will be under thing. So let's see here, we create food, okay, as one class. Under food, we can consider the main class pizza. And of course, pizza could have the class, another related class that we can think of is pizza topping, as well as pizza base. Pizza base means the bread. When we create a pizza, you need a bread for the base, right? The thick bread, thin bread, and so on. You need to add toppings such as many cheeses, sausages, olive, what else, right? These are the toppings. And so bread and topping, both of them combined together become a pizza. So again, back when I commented on your RDF schema, don't come with anything such that, how can I delete everything? No. Don't do that. Pizza topping is a subclass of pizza. No. Why? Remember, everything is a subclass of something when it is itself is also an object of that class, right? Is pizza topping a pizza? Never. You cannot order a pizza and then you get pizza topping, right? Pizza topping is just the cheese, it's just the tomato, the olive, and so on. It's not pizza. Never model pizza topping as a class of pizza. They are related, fine, but they are not subclass, okay? The same for pizza base. If you order a pizza, you get from the shop just the bread. Is that what you want? No, right? So pizza base is also not a subclass of pizza. Don't do that. This example is fine, but when you are going to model things for yourself, for your mini project or something, okay, this is common mistake that I will need to warn this first, okay? But maybe we will see. We will see. But I may need to have a checklist before you make a presentation or submit any ontology to me of your design. Check the subclass that is real subclass or not. Okay, anyway, so look at this. If we talk about pizza base, okay, this is easy. There are two types of pizza base in this example, deep pan base and thin and crispy base. Okay, in my restaurant, this is my restaurant. So I want only two types of bread that you can choose. Then this is the base. But then my pizza will be classified further by having this thin and crispy pizza, meaning that it is made of that thin and crispy base, right? Then it becomes thin and crispy pizza. Then this is fine. Thin and crispy pizza is fine. It is a pizza with thin and crispy base and also with toppings, okay? It may have cheesy pizza as another subclass. And also we will define what does it mean by cheesy pizza. It means that by default, you need to assume, right, that it must have cheese. Otherwise, it's not cheesy. And it may have some other class defined here as name pizza. Name pizza means it's some name. For example, we have Margarita. Have you heard of margarita pizza? What does it have? Cheese and tomato sauce, right? Just the tomato. Yes, that's it. No meat. Okay. It may have some other name pizza like American hot, and so on. Okay. Back to the pizza topping. Then we can define many types of pizza topping, many subclasses, such as, remember, why do we need to do this? Because we need to answer something like, customer may want to say that I want pizza with cheese only. I want pizza with meat only. I want pizza with this and that. So you need to classify based on the topping, such as cheese topping, spicy topping, meat topping, vegetable topping, fruit topping, nut topping, and so on. Okay. These are the topping for pizza that I classify further. And it may have some further subclasses, such as for cheese topping, further I have mozzarella topping, maybe some other types of cheese too, but in this example, just simple one. Meat topping, I have chicken, hot spicy beef, maybe sausage, maybe this and that. Vegetable, we can define olive, mushroom, garlic topping. Okay, they all are topping. Things that are under topping must also be topping, right? They are subclasses and so on. Then next subclass here is something that we define as further things related to the taste of the pizza. Don't make the taste of pizza under pizza subclass, right? Taste is just taste, such as the taste in terms of spiciness. Then we define spiciness to be medium, mild, and hot. Okay. Okay. So remember, we need 4 things, right? As components, define classes, define properties. Oops. Okay, then define individuals or instances. Then we can add certain axioms. And we can run a reasoner to do some query and reasoning something. First, we will do the class. Every class must have a name, okay? And you can define the class hierarchy through subclass. And you can define that different subclasses, are they disjoint or not? For example, okay, this is first to create classes. From here, you could see we focus on just these 3 classes. In our ontology, we are not going to create very complete pizza ontology, but good enough, okay? We need 3 classes here: pizza topping, pizza, and pizza base. These are 3 classes. They are not subclasses of each other. They are both under food. They are all under food. But let's say I'm asking, are they disjoint? Do you know the concept of disjoint? What does it mean, disjoint? Again, please. Very good. A class, 2 classes are disjoint when members of both classes, when one member of one class is not a member of another class, right? No member of one class become a member of another class. So if you draw, I think we learn in very small time, the time when we are very small, Venn diagram. If this is class A and this is class B, every member of class A and every member of class B, they are not overlapping. These are disjoint, right? So are they disjoint? Could we have some pizza topping becoming a pizza? No. Could we have pizza base becoming a pizza? No. And pizza base and pizza topping, can we have disjoints? Do you want to have some bread to be topped on your pizza? Maybe not, right? Okay, consider that way, right? So they are all disjoint. Okay. All right. In our example, let's say that we are not going to have the food stuff. We start from pizza. Okay. Create 3 classes. Okay, you follow the interface later on. I think this is step by step and easy. I'm just explaining the idea of the ontology. We need these 3 classes, namely pizza topping, pizza base, pizza. In any order is fine. It will be sorted anywhere somehow later on. Don't worry. You can create through this interface. Even you can make the indentation to make the subclass. So if you want to say that under pizza there is cheese pizza, you can do like this using indentation, then it will be fine. And if you want everything to be disjoint, there will be interface for you to tick that make every class disjoint. Okay. And disjoints are talking about siblings because they have to be in the same level. Sibling means they have the same parent, then they are siblings. Such as here, under thing, this is the parent. This class thing is parent. These 3 classes are direct children of thing, right? So they are siblings and they all are disjoint. If we talk about cheese pizza and pizza, are they disjoint? No, because if this is cheese pizza, how can I draw pizza? Bigger or smaller? Inside or outside? Outside, yes. So cheese pizza is inside pizza, right? So they are not disjoint. Disjoint only defined for sibling classes, okay, but not subclass. Okay, then let's, what you have to do is make things like this. Create the class hierarchy. But how can, of course, before you can create this, you need to have the modeling concept of the pizza in mind, right? You can, but of course, this is given. And in that case, we call domain expert. I mean, how can you make this model? You must, if you are not the domain expert, you must consult a domain expert, right? Domain expert will help you. You may need to talk to, interview, work with domain experts in order to understand this kind of conceptualization, what class, upper, lower, subclass, superclass, more general, and so on. So here you could see pizza topping. These are those many types, subtypes, okay, class, subclass, pizza base also. All right. And I think this is clear. We have the class pizza topping, the big circle. Inside pizza topping, we do have vegetable topping. Inside vegetable topping, you may have tomato topping, right? And this explain, I mean, this diagram tells you the subclass is smaller set inside the superclass, right? So everything that is a subclass will become automatically the superclass. And this way, if you try to draw, you will never miss concept, misconceptualization of creating class and superclass. Okay. Then that's all done first for the class. Next is properties. There are two types of property. Remember, object property and data type property. Okay. Let's look at some further detail. Object property is used to relate two instances, two objects. Data type property is just an attribute of an instance having certain literal value. That's it. For example, if these two are instances, Matthew and Gemma, relationship is has sister. This is a property. This is an object property because it links or relates two instances. But this one, Matthew, is an instance. Has age is a property, but this has age has a value 25. So this is data type property because the value of this property is just literal. Okay? So you have two types of properties to be defined in Protege, whether it is object property or data type property. That's it. And this way you can later on define domain and range as we already learned before. So let's say that I have the property, the first one called has ingredient, in which the domain supposed to be pizza class. The range supposed to be some other class, which could be the topping, which could be the pizza base, because these are the ingredients, right? So I define this as a property, as ingredient, and for sure, because it relates objects of two classes or instances, it is for sure object property or data type property. Object property, right? And it has sub property, two sub properties in this, has topping and has base, meaning that has topping is a special kind of has ingredient, right? A special property, a specialized property. Has base is also kind of subtype of has ingredient. Okay. And you can define, create object properties and use indentation to make sub-property too. Okay. And what else we can do? We can define inverse property. Inverse property means it's another direction, such as, remember my previous example? John and Mary. What example I use? Has a wife of and husband of. So these are inverse. Once you know wife of, you know husband of. It is inverse. So we can define inverse. In this example, has ingredient is a property. A pizza has ingredient something. Then that something is an ingredient of a pizza, right? It is an inverse. The same for has topping. This pizza has cheese as a topping, has mozzarella cheese. Mozzarella cheese is a topping of that pizza. The same, okay? Has base too. Same thing. Is base of is the inverse. So you can define, create new properties and define that they are inverse of each other. Okay, is base of is an inverse of has base. is topping is an inverse of has topping, and so on. Just follow the GUI is simple. Just click, click, tick, tick, check, check. Okay. Okay, this is the example diagram illustrating that pizza class and oops, need to be careful of my touching. Okay, pizza class and pizza topping class are relates with has topping. Okay, so if this pizza has this topping, then it means this topping is topping of this pizza, right? That's just the direction. So you follow the direction here and direction back. Okay. And it allows what? When you define the instance value and relation, you define only one direction. Inferencing or reasoning mechanism will do the inverse for you. You don't need to explicitly define everything, right? You explain only one knowledge, one thing, you know. Then the other way around will be infer automatically by the reasoning engine. This way, you allow that people can ask questions several ways, but then still your knowledge engine can answer. Okay. So next is to define domain and range, and that is easy as well. You just click and say specify that for the has topping property. Its domain is pizza, its range is pizza topping. And the same, similarly, has base. What is the domain? Pizza, and the range? Pizza base, yes. Okay, and what else? Transitive. Transitive means let's look at an example. It's easier. Transitive means when A has relationship X with B and B has relationship X with C, then A will have the same relationship X with Z as well. That's the transitive relationship. For example, Matthew has Peter as ancestor Peter. Peter has ancestor William. Then Matthew also has ancestor William. This is transitive property. So if we define, for example, has ingredients with transitive property. So let's say that a pizza topping, if pizza A, okay, has ingredient. Remember, has ingredient is a super property of has topping and has base. Pizza A has ingredient something. Okay. And that something has ingredient. Ingredient. Something else. Okay. It means pizza A also has the ingredient something else too, right? This way allows customer to query something with the chain, the transitive, because if you say that I am allergic to cheese because I have maybe lactose intolerant, okay, I cannot eat cheese. So it may not say that pizza A has the ingredient of that cheese, but something else that is used to cook pizza in the ingredient, something A has cheese somewhere. Then maybe we need to be able to reason and find that no cheese is found anywhere in every ingredient used, right? The same if we are strict, I am strict vegetarian, meat cannot be added into my pizza, but also if some other ingredient somehow has some meat-based stuff, I cannot eat too, right? So I need to make sure that this transitive property works. So we need this has ingredient to be defined as transitive. And to do this, you can simply use the checkbox again that which property is transitive. Then when you do the query and reasoning, it will work for you. So we say that transitive has ingredient is transitive. And functional property. Example is here. When has base, a pizza, right? It is a pizza has base, which is pizza base. And we want to say that this has base is functional. It means that the kind of the cardinality of has base is just one. So, I mean, your pizza can have only one base. You cannot have double base, right? It's not a sandwich. Then you have only one base. So that is to define it as functional, okay? The range, the value, the object, the instance that is related through this property is only one instance. Similar to has spouse. I mean, in general, right? Has spouse seems should be a functional, right? We are allowed to have only one spouse, okay? Something like that. Okay. Next is creating data property. This is easy because it's just literal. So you can do the same. Similar way to create an object property, but it's just different tab or something, different tab. And such as here, we can define data type, which is called has calorific content value. I would just say has calorie to be easy word, but anyway, it's the same thing, okay? So we want this has calorific content value to have the range, which is integer. The domain, of course, is pizza, right? Pizza has this calorie, and the range must be integer value. Okay. Another type of properties you can create is called annotation. Good ontology should be human readable and also easy to maintain. And that means you need to have some annotations for humans to understand what it is. These are a set of annotation for your ontology, such as comment, label, and many other things, see also, and so on. So be sure to every time when creating an ontology, add the annotation properties to describe your own ontology and describe each of the class property you define. Okay, such as here, we add comment for this is annotation for the whole ontology. Okay, it's a description of your pizza ontology. So we can say that it is a pizza ontology that describes every pizza based on the toppings. But each specific class, property, and so on, you can also add the annotation to your class too. Okay, then this is the result of ontology annotation after you add it. We use RDFS comment. Remember when you go to DBpedia, most of the objects in DBpedia, when you list, they will have comments. Comment is one common way to annotate everything, okay, including ontology, instance, class, properties. So once you have your ontology, you can define the ontology URI, okay. You can define the comment and very many things, okay. And as already mentioned, we can create annotation for classes too, such as margarita pizza. We add comment saying that is a pizza that has only mozzarella and tomato toppings. This is definition or comment or annotation of margarita. Don't forget to define the data type so that it's kind of properly set. And okay. Next is that you can create individuals. Individuals now, you can create many things, okay, many individuals. First one is country, because we want to define that which the origination of certain pizza is from which country, for example. We can create type or class country and define the two instances, such as America and Italy. Never define these two things as class, right? Italy is not a class, America is not a class, but it's a country instance, right? So this thing you should be able to understand when things are class, when things are instance. Okay. Now, suppose that everything is fine. We can do further for the okay, let me see. I think we still need some time, but shall we do like this? I'm tired. That's the thing. So I try to negotiate. So we stop here. Okay, this is what I'm going to negotiate now. We stop here on this slide number 20. We finish up to 28. Okay. We can continue next time, but I will continue explaining, but I want you to follow and go through everything until the end. Understand or not? Let's try. Okay.